These video notes cover Section 2.1 from your textbook, Variables and Assignments. Variables can be thought of like small boxes where we put things into them. We use these boxes as storage for important data and information from our programs. However, it is possible that over time, what's in the box is not that important to us. In C++, variables are names for memory locations. You can think of those memory locations as boxes that hold important data and information. We can write values into them, and we can change what's stored in those memory locations as well. However, we cannot erase the memory location. There's always something in there. Here is a sample program from your textbook. In this program, at the top of the main function, we see three variables declared. The first one has the word int in front of it and is named number of bars. On the following line, we see two variables that are of type double, named oneweight and total weight. If we have multiple variables to declare, we can put them on one line separated by commas, as long as they're of the same type. A little bit further down in the program, we see that we read in a value for oneweight from the keyboard, and we read in a value for number of bars from the keyboard, and the variable total weight is then assigned the value of oneweight times the number of bars. In order to use variables, we have to give them a name. This is called its identifier, but we usually just refer to it as the name of the variable. It's important that we choose meaningful names that give us a good clue as to what it represents in the program. When we name our variables, the first character should start with a letter. After that, you can use letters, numbers, or the underscore character. Every programming language has a set of special words called reserved words or keywords that have special meaning. You cannot use these as identifiers to name variables. Can you think of a few of these special words? You can pick them out because the IDE will color code them. How about int, double, return? In order to use a variable, it must first be declared. We do that by identifying what its type should be and then naming it. We're telling the compiler the type of data that we want to store. Here we see that we are declaring an integer named number of bars. And remember that integers are counting numbers or whole numbers. On the following line, we declare two variables of type double. The first is named oneweight using the underscore style of coding. The second is named total weight. I recommend that you use the camel case style that you see here for number of bars and total weight. I recommend that you use the camel case style of notation as it's less stressful on your fingers for typing, and it's become pretty standard in programming practice. The double type is different from the int type in that it can have a fractional component. These are really different the way they're stored in memory, and the addition and subtraction and multiplication and division of these types of variables are also done differently. C++ will be checking to be sure that when you declare a variable to be type int, you don't try to store a number that has a fractional component, even if that fractional component is 0.0. When you declare the variables, the rule is that it has to be declared before you can give it a value or use it. So you can declare all your variables at the top of your program main if you like, or you can declare it right before you go to use it. That tends to be the style I use. I keep my variables close to where I'm using them. Here are some more examples of declaring variables. Note that the end of the program line must end with a semicolon. So whether we have one variable declared, such as double moon distance, or multiple variables declared, such as int age, num students, at the end of the line, you must have that semicolon. The assignment is used to change the value of the variable. Here we see the addition of one weight plus the number of bars assigned to total weight. So everything on the right side of the equal sign, which is called the assignment operator, gets done before the actual assignment or changing of the value for what's on the left side is done. The assignment statement also needs to end with a semicolon, as most lines of code in C++ require. Here are some examples of doing assignment. The first example assigns a constant value, 21, to age. The second one uses a variable to assign another variable, and that's perfectly fine so long as they are of the same type. And the third example does a calculation using the expression diameter times pi. That will be computed first. The result will then be assigned to circumference. Programming is a little bit different than mathematics, especially when it comes to the equal sign. It's not an equal sign by itself. The equal sign is called the assignment operator. It is not the equality operator, as it might represent in mathematics. This line of code takes the value stored in number of bars, adds 3 to it, and then puts the new value back into the location associated with number of bars. This is why we call it a variable. We can change its value. When we want to give it an initial value, we can do that in one line of code or in two. The first example is showing declaring the variable on one line and then assigning it an initial value on the second line. Declare double miles per gallon, initialize by defining it with 26.3 on the second line. It is also perfectly acceptable to declare and initialize in one line. In this method 1 example, we see the declaration, MPG, and then the assignment of 26.3 of its initial value. The area variable gets assigned a value of 0 initially, and volume has not been given an initial value. But remember, there is a value in that memory location. Method 2 shows that instead of using the assignment operator, we can put the values inside parentheses to do the initialization. Most programmers use method 1, declaration with the assignment operator for the initialization. This is the end of section 2.1. You should review the conclusions, and now you're ready to try the practice program exercises at the end of section 2.1. Happy C++ coding!